So hello everyone, welcome to this new session. So in this session we are going to solve one more problem related to root locus, okay, which is having one of the zeros here, okay, in the numerator you can see, okay. So we have solved one problem in the last session, right? So again my request is to you all, please refer the full video, okay. In order to understand these kind of problems you need to be checking each step very carefully, okay. So this is the one more type of question here. You need to sketch the root locus of the given control system with the open transfer function g of s into h of s is equal to k into s plus 5 divided by s square plus 4s plus 20, okay. So now let's do this step by step. First thing is, step 1 is seeing the number of root loci, right? For that we need to be knowing number of poles and zeros. So zeros, in this case we are having 1 zeros here. If you see here, s to the power 1, so we are 1 zeros, and number of poles are s square plus 4s plus 20. So if we want to calculate number of poles, we need to equating the denominator to 0. So if we have one quadratic polynomial, so it's obvious that we would be having two poles. So we have 1 zeros and 2 poles. So the zeros here is s is equal to s plus 5 equal to 0, so s is equal to minus 5, and the poles are s is equal to, so this is one equation here. So I've told you how to represent that equation in the calculator. Mod 5 equation, then ax square plus bx plus c, that is 3, then write all the coefficients, that is 1, put equal to sign, 4 equal to, 20 equal to, so the roots obtained are minus 2 plus 4i. So one root is minus 2 plus 4i, and the other root is minus 2 minus 4i, okay. So here if you see in this problem, you can observe that we are getting complex poles, okay. So if we have complex poles, I've told you, right, one rule would be getting activated here, that is the rule of calculating angle of departure, okay. So now in this problem we are going to go through the angle of departure, okay. So before that, let's do the previous steps. So the next step is number of root loci, okay, that is maximum of p comma z. So the maximum of 2 comma 1 is 2, so number of root loci is 2. So we are going to get 2 root loci, or we can say that simply we are going to get 2 branches, okay. So now let's solve further, that is step 2. Number of asymptotes, or we can say number of straight lines, is again number of poles minus number of zeros. Poles are 2, zeros are 1, so number of asymptotes here we are getting it as a single asymptote, and we can say that there is a single straight line, okay. So that's why now the third step is angle of asymptotes, okay. Before that we need to be finding, since we have one number of asymptotes, so we need to be calculating only one single angle of asymptote. If we have only one angle of asymptote, the values of q would be only 0, okay. So that's why our theta 1 or theta is equal to 2 into 0 plus 1 into 180 degree divided by p minus z, that is 2 minus 1, that is equal to 2 into 0 is 0 plus 1 is 1, 180 into 1, 180 degree divided by 2 minus 1 is 1. So we are getting only one single angle, that is 180 degree, okay. So this would be plotting in the graph. So the next step is centroid calculation, right? Sigma centroid, that is summation of real part of poles minus summation of real part of zeros divided by p minus z, right? That is equal to summation of real part of poles, okay. So here that's why they have mentioned it as real part of poles. Sometimes the poles which we get is complex, right? So in this, what are the real part of poles here? Minus 2 and minus 2, okay. We need to sum it up, that is minus 2 minus 2 is minus 4 minus real part of zeros, that is minus 5. So minus of minus 5 divided by p minus z is 1, so minus 4 plus 5 is 1, so 1 by 1, so our sigma we are getting it as 1, okay. But I forgot to tell you, right, the centroid should always be less than 0. Okay, that there is one condition for centroid, that it should be always less than 0. Okay, so here in this case we have got centroid as 1. So whenever we get centroid greater than 0, that centroid doesn't exist at all. Centroid won't exist whenever sigma is greater than 0. Okay, so there is no use of calculating this centroid at all. So in the when you are trying to plot, the centroid is not required. Okay, so that's why. Now step 5, that is determining breakaway point, right? So now here we are going to have a bit of a problem now. Breakaway point, that is 1 plus g of s into h of s is equal to 0. Okay, so that is 1 plus g of s into h of s. In the question they have given it as k into s plus 5 divided by s square plus 4s plus 20 is equal to 0. Okay, so now cross multiply s square plus 4s plus 20 plus ks plus 5k equal to 0. I multiply this k to both the terms equal to 0. Okay, so that's why s square, here we have 4s and ks, so we can take 4 plus k common s, and 20 plus 5k also we can take it together because k is a constant again, so that's why we can take this 20 plus 5k together and we can directly write it as equal to 0. So this is the characteristic equation which we have obtained, so which we are this equation we are going to use it later. Okay, so now using this equation, try to find the value of k. Okay, so now using this equation, try to find the value of k. First thing is, wherever the k terms are there, equate it. So that is s square plus 4s plus 20 plus k into s plus 5 equal to 0. So our k into s plus 5 would be equal to, if you bring this whole term to other side, it would be minus s square minus 4s minus 20. So our k value would be minus s square minus 4s minus 20 divided by s plus 5, right? So this is the value of k. Okay, so the next step to determine breakaway point is we need to doing dk by ds is equal to 0, right? So now here comes some calculation part. Now we need to be taking the derivative of this term. So here it is of the form of u by v, so we need to be using u by v rule now. That is dk by ds is equal to denominator square first, then numerator as it is minus 20 into the differentiation of denominator with respect to s, so this is 0 and differentiation of s is 1, minus denominator as it is into differentiation of numerator, that is minus s square is minus 2s and minus 4s differentiation is minus 4. Okay, so now this is equal to 0. So if we bring this whole term s plus 5 whole square to other side, so that is again 0. So we can directly write it as, so this term into 1 is same, this term itself, that is minus s square minus 4s minus 20 minus of s plus 5, and here we can take this minus common. Okay, minus 2s minus 4, so minus of 2s plus 4 equal to 0. So if you observe carefully, this is one term and this is one term, these both are getting multiplied, so minus into minus is plus, so minus s square minus 4s minus 20 plus s plus 5 into 2s plus 4 equal to 0. So minus s square minus 4s minus 20, then solve this, s into 2s is plus 2s square plus 4s, 5 into 2s is 10s, 5 into 4 is 20 equal to 0. So we can cancel this minus 20 plus 20 here, plus 4s minus 4s and plus 4s, so remaining term is minus s square, so minus s square and plus 2s square, so this is plus s square, and we have here 10s. Okay, plus 10s equal to 0. So here we have obtained one equation that is of quadratic form. So in order to find the roots, again use the calculator. Okay, the same procedure. Okay, so that from that time I have done one calculation, right? So that's why I have cleared it. In order to clear this, we need to press AC. Okay, then again write the coefficients of s square in place of a, that is 1, and in place of b write the coefficient of s, that is 10, and c we don't have any term, so write it 0 and enter it. So these are the two roots we are obtained. One root is -10, another root is 0. Okay, so these are the two roots here, but this 0 is not a valid breakaway point, because this 0 lies on the origin, right? So we have only one breakaway point in this case, that is breakaway point is equal to -10. Okay, so this we need to be plotting in the graph. Okay, so now we have one more step, that is step 6, angle of departure, right? So now before calculating this angle of departure and what does this mean, okay, so first I'll write the formula and keep 180 degree minus summation theta p minus summation theta z. Okay, so before calculating this angle of departure, I have left some space here. Okay, first let's calculate the next step. Okay, I will be telling you why I am calculating the angle of departure later. I am going to calculate this angle of departure when I do the plot. Okay, so I will tell you why. In order to make the calculation easier, I am doing it. So now first let's directly do the next seventh step, that is point of intersection on imaginary axis. Okay, so let's take the characteristic equation s square plus 4 plus kx, which I have solved during breakaway point. That only I am taking 20 plus 5k equal to 0. Okay, this is the characteristic equation. For this, try to draw the Routh array. S square, s power 1, s power 0. Coefficient of s square is 1. Skip this term. Coefficient is 20 plus 5k and 0. Coefficient of s power 1 is 4 plus k, and here if you skip this term, we don't have any term, so 0. So 4 plus k into 20 plus 5k minus 0 divided by 4 plus k. So 4 plus k would be getting cancelled. So this term only would be coming here. Okay, 20 plus 5k. So now after that, we know that 20 plus 5k should be greater than 0. Okay, in order to satisfy the RH criteria. So therefore, the above this term, that is 4 plus k equal to kmar now. In order to do this as a row of zeros, so our k margin value, we are getting it as -4. So now do a of s is equal to 0, that is above the row of zeros, that is we have s square plus 20 plus 5 k is equal to k margin equal to 0, s square plus 20 plus 5 into marginal value is -4 equal to 0, s square plus 20 minus 20, 5 4s are 20, in plus into minus equal to 0. So this gets cancelled, so s square equal to 0, so s is equal to 0 we got. So if we get s is equal to 0, or if we do not get, when we solve for s, if we do not get any imaginary term, we can directly write one thing, that is there is no point of intersection. Okay, if we are not getting any imaginary values, we should directly write as no point of intersection. If it gets 0 or any non-imaginary values, directly we can write it as no point of intersection. Okay, yeah, because this rule is only applicable for in order to find the intersection in imaginary axis. Okay, so that's why in order to find the intersection of imaginary axis, we need the imaginary term as our result. Okay, if you don't get any imaginary term, directly write it as no point of intersection. Okay, so now let's try to draw the plot of this problem. So again, I have drawn the imaginary and real axis graph here. Okay, now let's try to mark the poles as well as zeros. So we have 1 0 at s is equal to -5, right? So let's represent that 0 like this. The 0 is already represented like this. Okay, and the two poles are -2 plus 4i and -2 minus 4i. So -2 plus 4i. So we are having one pole here like this, and -2 minus 4i. So we have one more pole like this here. Okay, so these are the two poles. So whenever we get some complex poles like this, it's better if you join those poles like this. Okay, join these two poles like this with respect to the imaginary axis, that is like this. Okay, join these two poles like this and keep. Okay, I will tell you why. So now what we need to be doing is, next thing is centroid, right? Centroid, we know that we have got the centroid value as positive. See, so it doesn't, so here don't have any centroid here, so I'm marking minus infinity here. So if we don't have any centroid, from that point of centroid we don't need to mark any angle of asymptotes also. Okay, see in this problem also, if we see very carefully, the angle of asymptotes we have only got single angle of asymptotes, that also we have got it as 180 degree only. Okay, so if we plot it, and if you don't plot it also, it remains the same, because 180 degree means it's a straight line. So, and also the centroid we have got it as positive, so no need of marking the angle of asymptotes in this case. Okay, so but we have got one breakaway point here, right? Minus 10. Yeah, so mark that breakaway point here. Okay, highlight like this in minus 10. Then now there is the task of finding the root locus, and for that, since the poles are on the, what to say, S plane, not on the symmetric with the real axis, it is on the plane here, it is on the surface, it's not on the real axis or the imaginary axis. But see, in order to see in which direction the branches are moving, in case of the imaginary poles, we need to be finding the angle of departure. Okay, that is, in which angle from this pole we need to be finding one angle, and from this pole we need to be finding one angle. That is, so if we find one angle with respect to this pole, the whatever angle we get, its mirror image, the angle is here only. Okay, so that's why in order to find angle of departure, we need to be finding for two different poles. But in this case, since the poles here are in the same line, so that's why if we get any one angle here of departure, okay, the opposite of this angle or the mirror image of this angle we need to be drawing here. Okay, so that's why in this case we need to be finding only one single angle of departure. Okay, so let's see how to find that angle of departure now using the graph only. Okay, so angle of departure, I've written it like this, right? The formula is theta d minus 180 divided 180, theta d is equal to 180 minus summation theta p minus summation theta z. So we need to be finding separately summation of theta p. Okay, that is theta p1 as well as theta p2. Okay, how to find these two angles now, theta p1 and theta p2. Okay, so here we are finding the angle of departure with respect to this pole now. Okay, we are finding an angle of departure in this pole. Okay, so that's why in order, when we are finding summation theta p, it's not required that we need to find this angle theta p2. Let's name this pole as p1 and p2 in general. Okay, so that's why just try to find the angle of theta p1 with respect to the pole 2 and the origin. Okay, so we need to like in this way we need to be finding the angles made by the poles. Okay, poles, since we are calculating the angle of departure with respect to this pole, so that's why the angle made by this pole with respect to the pole 2 and origin, this is the angle made, right, from this pole and this origin. Okay, one line should be moving towards the pole and one line should be moving towards the origin. Okay, so the angle made by pole 1 is 90 degree, as you can see, this is 90 degree, you can see, right? So directly we can write it as theta p1 is equal to 90 degree. Okay, or since we are calculating only one angle theta p1, so directly we can write summation theta p is equal to 90 degree, that is angle made by pole with respect to pole 2, because we are calculating angle of departure in this pole, right? So that's why this is 90 degree. So now summation theta z. Okay, so since we have only one single 0 here, okay, angle made by this 0 is how much? Okay, how to calculate angle made by this 0 with respect to this pole and origin? What we can do is, angle made by this 0 with respect to origin and this pole, we can join this like this here. Okay, and whatever the angle we get, try to measure it. Okay, so here in this case approximately I am getting it somewhere around 53. Okay, 53 degree. Okay, so in this way from graph we can find out angle. Also theoretically we can find this angle, that is theta z is equal to tan inverse of, in this triangle, opposite side by adjacent side. Okay, opposite by adjacent, like this we can find. Okay, that is theta z is equal to tan inverse of opposite angle, opposite side here is, this side is opposite, right? And if we check the scale here, we have 1 2 3 4. Okay, so we can write this opposite side is equal to some 4. Its length is 4 units, so 4 divided by adjacent side. Okay, that is, this is the adjacent side, and its length is 1 2 3. Okay, the length is 3 units, that is 4 by 3. Okay, so if we put that value in the calculator, that is, if we put the value of tan inverse, that is tan inverse of 4 divided by 3, see the answer we are getting approximately equal to 53 only, that is 53.13. Okay, so angle made by theta z is equal to 53.1 degree. Okay, that is summation theta z is equal to 53.1 degree. Okay, but also we can see that from the plot only we are getting the same angle, right? If we check it from here with respect to this pole and origin, we are getting somewhere around 50 55, between 50 and 60, somewhere around 53 we are getting it. Okay, so that's why these are the two ways you can directly, either you can directly plot it from here, or you can calculate it like this by formula of tan inverse of opposite by adjacent. So now we have got summation theta p, summation theta z. So now try to calculate theta d with respect to pole 2. We are calculating theta d on angle pole 2, right? So that is 180 minus summation theta p is 90 degree minus summation theta z is 53.1 degree approximately. That is 180 degree minus 90 minus 53.1. If we solve it, we are getting 36.9. So 180 minus 36.9 is 143.1 degree. So theta d with respect to P2 is somewhere around 143 degree. Okay, so now this 143 degree we are going to plot it from this point, that is pole 2. Since we are calculating with respect to pole 2, so that's why if we get angle as 143 here, the same mirror image angle we are getting here with respect to pole 1 also, that is minus 143 degree. So we can directly write it as theta d of P1 is equal to minus 143.1 degree with respect to pole 1. Since these poles are in the same direction, one is plus and one is minus, so that's why whatever angle we get here, the mirror image same angle we are getting it here. So now plot this angle here from this point somewhere around 143. Okay, plot it, try to plot an angle of 143 degree from here. Okay, same thing, the mirror image from here ulta, that is minus 143 degree. Okay, that is from here, this is 140, right? So here this is 140, somewhere around here we would be getting 143 degree. After that, join that angle of departure. Okay, and here also from this point to this point, join that angle of departure. Okay, so like this we are getting one plot now. Okay, so now how to draw the root locus? Okay, so this is the breakaway point, and from this pole this is the angle of departure. Okay, that is from this pole one branch would be moving towards this moving towards the angle of departure with the angle created by it, that is approximately 143 degree. Okay, moving, it would be moving towards the breakaway point. Okay, so from here one branch would be moving like this with the angle, and here it would be touching this breakaway point. Okay, and from this breakaway point and also from this pole with the same angle created, it would be moving like this and it would be touching this breakaway point. Okay, then after that, since we have 1 0 and these are the two branches, that is, it's moving in this direction here. Okay, here these two branches are meeting, but these two branches also won't go to infinity. Why? Because we have 1 0 here. Okay, if we have 1 0, we know that one of the branch would be terminating at 0 and other would be terminating at infinity. Okay, we cannot say that which is terminating at 0 or infinity. We can simply write that, for example, let me take this pole, and from this here it's meeting the breakaway point, and let me take this pole is moving towards 0, and this pole from breakaway point it is moving towards infinity. Okay, so that's why from this one pole the it is moving towards breakaway point, and from breakaway point it is moving towards 0, and from this pole one branch is moving towards breakaway point and it is moving towards infinity. Okay, so this is the second root locus plot here. Okay, you can observe it. So that's all for this session. So hope you understood this problem very well. So please like, share, subscribe, and also refer our previous video. We have solved one more important problem in the previous video also. Also refer the rules of construction of this root locus thoroughly, and please try to watch the full video, okay, in order to understand the problems very carefully. Okay, in the next upcoming sessions also we are going to solve same kind of problems but some difficult type. And also like, share, subscribe, and also refer our previous videos. The playlist is available. You might be seeing on the right of your screen now. Refer those videos. Also model paper solutions are also we are going to provide it to you all. So that's all. Thank you.